Hello everyone, welcome to editorial video of Codeforces Round 816 problem D, and in this problem we are given an array of n elements and the elements are unknown for us initially, and we are also given q statements, and each statement will be like I, j and x, where ai or aj is equal to x, where or is the bitwise or operator basically. So what we need to find is we need to find the lexicographically smallest array a which satisfies all these q conditions. So let's look at this problem. So what we will observe is we have to do the bitwise OR operation, and bitwise OR operation is independent of other bits. Like if I am doing a bitwise OR of two numbers for the fifth bit, then fourth bit, third bit, and so on, sixth bit won't like interfere in this operation of fifth bit, right? So what we can observe is we have 29 bits to 0 bits uh, for every AI. I think it's, yeah, it's less than 2 to the power 30. So we will have in total 30 bits, and if we solve for these 30 bits individually, then my problem is solved. Now what is the benefit of solving this for each bit? We will have like this x will either be 0 or 1 that we are having, because we are taking it into binary terms as actually. So now how to like proceed in this problem after this observation? So what we will do is, first of all, let me copy this test case. Okay, so these are x, right? So I will convert each of this x into the binary form. This will be 1 1, this will be 1 0, this will be 1 0 as well. This is a 0th bit and this is the first bit. Okay, now what we will observe is, okay, so let's observe this statement. This statement says that a1 or a2 for the 0th bit is 1. What does this mean? Either a1 का ith bit is 1 or a2 का ith bit is 1, or both of them, a1's ith bit and a2's ith bit is 1, both of them is 1. So which of the case is like not accepted? So if this x is 1, then a1 can't be 0 and a2 can't be 0 uh, together. So this I'm talking about the ith bit. If we take the counter of this example, if for this example, what we will notice that suppose x is 0, then what we have is a1 can't be 1 and a2 can't be 1 in together for ith bit, right? And from here we got the idea. How? What we will do is, for each bit we will create graph out of this q statements. How will we create graph out of this q statements? Let me tell you. Just a second, let me copy this thing. Yes, so how will we make the graph? How will we make the graph? So first of all, we are given that from 1 to 2, for 0th bit this edge weight will be 1. From 1 to 3 the edge weight will be 0. From 1 to 4 the edge weight will be 0 again, and we will observe that like 1 to 4, like 1 4 is similar to 4 1, because a1 uh, or a4 is similar to a4 or a1, right? So this will be an undirected graph from this observation. Now what we will do is we will initially set the ith bit of all the numbers as 1, right? Now we will use that property, like if the edge weight is 0, this can't be 1, so we will unset it, we will unset it, we will unset it, and this is the first step. Now after doing this step, we will have a we will have an arrangement that follows all the q statements. But what we need is, we need the lexicographically smallest array, right? So what we will observe is, after like in the contest, after observing a bit, I got to this situation where suppose uh, I'm doing a subgraph. So each of the edge weight is 1, and each of their, suppose, uh, bits is also set. Now what we will observe is, let's observe for this thing, this thing. What we will notice is, if we unset this, then also uh, the all the Q statements must be following the convention. How? If the edge weight is 1, then OR of these two elements will be 1, which is same holds for 2 and 5, same holds for 2 and 6, same holds for 2 and 9. So what we can do is, we can unset this bit, and yes, this will be like lexicographically smaller than the previous um, uh, array when we were not unsetting this bit, right? So how will we like convert the answer to the lexicographically smallest answer? So we will notice that if I am at any index, right, and if this index is set, and this might be having some edges going to some nodes, and these nodes will have edges will have some edge weight. Now if this edge weight is set, if this edge weight is set, if which means that the edge weight is 1, and uh, each of the like subsequent uh, nodes has also their ith bit set, then we will definitely remove this. And what will be the counterpart? The counterpart will be this case, if this is not set. So if we unset this, this will like it will not follow the rule. Which rule? The XOR of 0, the OR of 0 and 0 is not 1, right? So we can't set this. So I'll show you the code. It will be like pretty much clear, because it's just basic simple like bit manipulation after all. So what I'm doing is, first of all, I'm taking the input as a graph. Now I'm initializing each, I'm setting each bit from 0 to 29 for every element from I equal to 1 to n, right? Now for every bit I'm running this for loop. For every bit I am solving the problem independently. Now for this, in this loop, from line number 67 to line number 76, what I am doing is I am solving this problem that I told you about here, right? I am setting every bit, I already set every bit as 1. Now if I saw a 0, edge weight as 0, and I'll unset both of the connecting elements as 0. So yes, so if this edge weight is uh, so first of all, I will have to check that if that element is set or not, and I will go to like every edge of that element, and if this edge weight is unset, and if this edge weight is not set, which is 0, then I will have to like unset the bit of this of the current element right now, and I'll break out even if I found only one element, because it is like enough to do that. Now in this loop, what I am doing is I am making the answer lexicographically smallest, and I am following this algorithm that I told you over here. What I'll do is, if the jth, if the ith bit of element j is set, then what I will do is, initially I'll unset it, and I will go to each and every edge, and if that edge weight is 1, and uh, it is connecting to a to a index whose ith bit is unset, then I won't be able to like unset it, because it will boil down to this case 010, right? And this, which is not mathematically correct, so I won't be able to do that. So I will like set this bit again and break out of the loop, right? And after that I will have my answer stored in the array, so I'll like print it out. And that was all about this problem. I hope you understood the problem. uh, Thank you for watching this video, and have a nice day.